Hello. Hello everyone. Can you hear me? Can someone just give me a confirmation? Cool. Thank you. So hope you are doing good. Good morning. Uh, Today I'm gonna cover a very important concept called federation, and then we'll also look at some of the directive conversation that we left yesterday. So just to uh, reiterate on what we were learning yesterday about directives was more about, okay, let's skip through it. We had this, we had the n+1 problem, data loaders, directives here. So directives basically are used to change the behavior of the application or change the behavior of your runtime application. And as you can see, you can annotate directives at any level and decorate your schema so that you can actually write business logic based on that decoration. It's more like it's more like customization or configuration to your schema, which can change, which you can add to add validation. And we'll see a few examples today of the directive itself. And this actually makes the GraphQL specification a lot more customizable and a lot more extensible. We will see a lot of examples today. One of the biggest usage of directive is federation itself, like where multiple GraphQL services are stitched together into a single schema, and that's where a lot of startups today are being created on that concept. And I think a lot of open source and or paid GraphQL technology projects are based off of directives, and people have created directives and extensions to GraphQL using directives and providing libraries, enterprise tools on top of it. Um, so let's look at. Okay, we did this. Let's look at a very simple directive example. As you can see in our example, we can just annotate the movie at line number 2 with Aussie and just specify a role for admin. And you can have any number of arguments or any number of inputs to the directive itself. So in this case, we have defined an Aussie directive on line number 5, and we're using that on uh, line number 2 and seeing that, hey, we're implementing authentication or authorization on our schema using that directive. When the role is admin, that it will be accessible. The client will be able to query movie operation only when the role is admin. That's what the meaning of directive is. If you can see the implementation itself, Aussie directive is a class, or Aussie directive is a has a bunch of method that you need to implement with the directive name itself. And visit field definition is one of the method which we are using in our implementation. And then once you have a visit field definition method implemented, that method is actually checking for if the correct role is provided in the request to the user, to the server. And if not, it will just it'll just say that the query is unsupported or unauthorized. And how do you actually inject the correct role? If you see on the right hand side, step 3, which is when a request comes in, you can actually add context to the Apollo server on line number 4. The request is basically the request that comes into the server. We are taking the authorization header, splitting it and it's basically a very simple authorization header. We'll see that in an example, and we just check the existence of admin in that header string. In that header, we're not using JWT yet, but that will give you the role that the query or the client has while making the query, and it injects context into your Apollo server. And if you see line number 17 to 19, that is where the ODG directive that we've defined on step 2 is actually being used. So all three of them, if you consider, we are kind of using the HTTP request that the client sends using an authorization header to enrich the context of the request or enrich the context of the GraphQL execution to the Apollo server. And when the runtime, the server automatically will start will start looking at the ODG directive, and because of the visit field definition, it will actually uh, execute this method in each and every whenever it visits each and every field inside the run, yeah, while executing the query. And if you see the actual implementation, there is a field on line number 3. The field is an argument inside field is an argument which is available to that method, and that field.resolve is a resolver that we've actually registered in the past. Now, what that method is actually doing is uh, it is checking for authorization, and if the authorization passes on line number 12, it sees that it will just execute the resolve method as it is, and if not, it will just throw out an error which will result in an error object in the body, which will result in an error object and the data will not be returned. So I think we will we'll go back to our example that we were looking at and take a look at it in a live session on the studio itself. Let me see if I can share. Okay, so let me share my screen. Cool. So we will go to the Explorer and we will try to query the same queries that we left yesterday and see if this works. So if you see, if I don't pass any authorization header, this is the header section in the studio. If you can look at it, I have not committed the code for the authorization yet because it's a little bit messy on my machine, but I promise that I will clean it up, simplify it so that it is easy to read and easy to understand. And uh, I'll publish the code to GitHub into a branch. So if you are already on that GitHub workshop, I'll definitely publish it and update the README with instructions on how to do ODSI. But for now, let's play along. Uh, so in here, first, I'm just passing no bearer token or no authorization header, and then it just tells me the ODSI. And if you see the errors object, this is also a classic example of how the errors look like. Um, Now I'll add the authorization header, and I think in the queries, I have a directive for ODSI. If you see the right hand side, I have a directive on ODSI, and I'm saying that the role should be either user or admin. And if I just do user, it should fetch me that data. I guess the server is authenticated is true. Okay, so maybe I don't have the correct token. Let me just take a login. So I also created a mutation called as login in my service, which will give me, I log in with a username and password. It will give me a token. So I'll take that token and I will try to use that. Okay. Yeah, So I had an expired token. That's why it was not working. Now I took a fresh token. I created a login query, which I'm just very simple query and mutation, which I'm using for my login operation. And I'm getting the token from the backend. And if you see here, I have a mutation for login, which takes a username and password and gives me the token. And then I use that token in here and it just works. I can change this to user also, and uh, because I have both the roles, it should work with user as well. Okay, the studio is a little bit slow for me for editing the headers. Yeah, so I think the token is very assigned to the user itself, and it is actually validating correctly on the backend that this should not be allowed. So, oops. Let's do all movies again. Yeah. So this is a mutation. This is a query. Okay. So so I have one more rule on my line 186, which is not allowing the movie to be accessed to the user, and that's where it was not showing up. Let me try that. Let me try another movie by language. And language will do movie. And then we'll just do my movie. So currently it's admin, so it's working fine. Let me change the user role to a user. Let's change the login. So for me, I think I have the login as user and user 123. That should give me a user token, and then I can take there. Oops, and headers. I can just hit. Yeah, so the user is not allowed for queries, but it should authentication equal to true. Okay, let's look at this. So query is only allowing the roles for admin. I think this is not published correctly. Let me just make sure I save it. Query is only allowing admin, mutation is allowed by admin and user. So that's right, it did the right thing. Let's look at why it's not updating. Okay, now the query is allowing admin and user. Now this should, I think this was not saved on my local, just having a problem with editor. So now if I do that, I should have access to movies by language, because movies by language does not have an additional directive here for the admin role. But if you see movie ID, it is actually only allowing the admin role. So the concept here is you can apply directives, the same directive at multiple places, and you can change the implementation in a way that in my case, I've actually made it a little bit nested, that all queries are available for admin and user. But just to demonstrate, I added the Aussie rule for line 186, that the movie ID query is only available for admin and not for not for any other role than admin. So when the execution actually happened, it will run the queries and it will try to apply these rules using the directive implementation and see if what role the request actually has, and then deny or allow the request to go to the next level. Next level meaning either it will just call the resolver or it will just throw out an error. In this case, we had three queries in our request, which is movies by language and two alias queries. The two alias queries were rejected and each one of them had a message, and the data was returned for this. So this is also like demonstrating the partial data that we were seeing in GraphQL in general. And if I just disable the header, I think I'll get three errors because the query itself is blocking all the operations are secure using the authorization header. So any questions on this directive concept or authorization concept so far? So the advantage and disadvantage of directive concept. I think the advantage, I don't see any disadvantage on directive, to be very honest. It's basically something which is optional. So it's up to you if you want to use directives or not. The advantage is that you don't have to write a lot of code in your resolvers or in your server to write rules related to the schema itself. So by now you must have understand that GraphQL, the backbone of the GraphQL is the schema file or schema definition language, right? Once you have that structure, most of your customization or most of your business logic also revolves around this schema definition itself. Now, we cannot have more and more fields in the schema itself or more arguments in the schema itself. And we cannot have arguments accepted from the clients in a lot of cases. Now, to add more customization or to the your APIs, you in the REST world usually you have configuration in the YAML that hey slash movies endpoint will probably have a certain rule or certain auth policies. I'm just taking an authorization example, but this is true for all other concepts. In REST, a lot of use cases usually revolve around the endpoint or the path or the resource, we call it in REST. In GraphQL, the schema itself is your resource. And in order to add customization to the schema, the custom in order to add customization to schema, your customization needs to be very close to the schema. You cannot have a separate file. You cannot have a separate file. You can actually have a separate file, but it will look very messy once you have rules like, hey, movie by language is in our example, movies by language is allowed by admin and user, etc. Movies or movie operation is allowed by admin itself. So if you try to keep these customization out of your main resource or out of the backbone of your service, it just gets too messy, and then you have two sources of truths. One is your schema file. For someone who's reading it, you will have to look at the schema, and then you have to look at this additional configuration where it specifies what the behavior of the schema is. So directives give you the liberty to actually write write customization or write any kind of behavioral driven changes to your schema close to your schema itself or close to your field definition and type definition itself. zoom in. So anyone, is the screen still visible? Which screen was not visible? I can share again. Okay, cool. Uh, can someone, I think, can Ayan comment on what screen needs to be zoomed? And one other thing is I can go over the code once again. Let me see. Okay. Yeah, as a React developer, should I learn GraphQL? I think it is important, and I would say yes. This is not a concept about React or non-React. I think this is just replacing your traditional REST APIs. That is my point of view. But there is a lot of libraries that are actually created for React, and I'll share one such library shortly, which is the Apollo client, and it fits very well in the React. React Redux store paradigm, and there's actually a lot of extensions where you can hydrate your components, React components, with direct GraphQL queries also. So there are libraries which are very React friendly, client libraries which are very React friendly. It supports caching and a lot more benefits. And usually, I've seen, at least in my company, all the React apps, it's all React UI, and everyone prefers GraphQL over REST in general because of the client libraries provides a lot of things for free. Uh, with that, I will jump into that application. I was actually playing around with writing a client application, and I wrote a few application. I wrote a small UI, and I will share that shortly. So let's look at this. So I will just do. So I'll just log in as. So I created a small web page as a client or a front end to demonstrate how it is actually integrated on React application, and also demonstrate how can we uh, how does the query actually look like when you actually making from front end to back end. And there's a small sign in which I have integrated. Forget about the images, and I was not able to fetch the right images from IMDb or anything, but I just created a page. But what I want to demonstrate is, let me do it again actually. Um, so I have this admin UI. Like I said, I'll open the network tab, and then let's do this. We'll look at the code, but let's look at the network calls that are going from front end to back end. We'll give you a better understanding. So I have an admin UI. Uh, I just log in. If you see, when I log in, there are two calls being made. One, the first call that was made to the. And let's look at the headers. The first payload is basically a login operation. The operation name could be anything. I think it should just be the same thing. Remember the three things that we actually looked at once we started. Query, where the actual query stays in a string format. Then there's variables, where I'm representing username and password. It represents the same query that we were seeing in Studio, which is the login query. But if you see, this is a very well structured query because we are in the Studio world. But when it actually goes out to make a network call, it actually follows a JSON structure with this payload. Okay. Then the response is basically what we were seeing there, and the client gets the response. It makes a second call, and let's see what second call it made. The second call it made was get top rated movies. It made the top rated movies query. And then I think it asked for 10 movies. Yeah, it limit was 10, and then it asked for all the information that it needs to display this page. Uh, Again, I think in the header it should, because it is getting the response, the header should have a bearer token for admin. Yes, you see this. Just zoom in a little bit more. So this is the header. This is the payload. The three things in the query, which is a JSON payload, and we can just view source. It's the same structured query that we were looking at. If you see this in the ID or the Studio, right? Then if you see the first query, and if you see this is the same query that we are looking at in the Studio with passing the username and the password. Type __ type name is a special operation which the client library that we will shortly look at actually passes by default. For each and every query, it just gets the type name information from the server. Also, this is an introspection field that you can ask the server. Now let's look at the, once you click on one of the movies, it actually fetches much more information from this. And the third query should be get movie by ID. We look at the code of each of them, but if you see this, let's look at this. Yeah, so it's asking mostly all the fields with the poster, description, director, and reviews also. And if you see the reviews, you can see the reviews for here. It's just displaying it twice, but that's what it does. And then you do back, and then let's see. This has only one review, so it's fetching the review correctly. And every time you do this, you get a new movie by ID. And let's try to do back again, and then do. Now, if you notice here, there was not a new call after 12 Angry Men. You didn't see, the last call was 12 Angry Men. You didn't see Shawshank being called. Because like I said, the client also, the client on the front end also does some kind of caching, and it provides it that out of the box, like the data loader was providing caching out of the box. There's some caching out of the box in the client side itself. So there's a lot of advantage using the GraphQL client at the front end level itself. Now we can do back, and we can again do 12 Angry Men. It will not do it. But if you do, let's say, Dark Knight, it will make the query, right? So there's this caching implemented which optimizes your app, and you see the response. The type name is always going to be the type of the object itself. In our schema, it was movie, and in our schema, it was a review. So you're getting the type name as review. Let us look at some code. So we saw one mutation going in there. This was mutation, right? Yeah, this was mutation. There was query. And then I also have a filter here, which filter the language using the movies using the language itself. And I think this should be that filter query. Yeah. So this query is now movies by language. and it is passing that language filter, which is accepting. If you see this variable, language is Hindi, it pass the filter. We can look at some of the code on the client side, but let me zoom that part. So client side, I just asked again, this is vibe coded, so this is not me writing the code. This was AI writing the code for me. So I have this index.js where you initialize your client. The client library is the Apollo client. You can, I have a link in one of the slides for Apollo client on how to use it. And if you see, this comes with an in-memory cache that you can have here, and then for every request, this will actually add a authorization header that it is expecting in the token. And then that's it. That's the only thing that you really need to do Apollo client or a GraphQL client. Apollo is a very popular library in GraphQL world. Apollo is a billion-dollar startup which actually started with open sourcing a lot of tools and libraries for GraphQL, but now they are actually paid. They also have come up with paid solutions and paid services, which a lot of companies are actually using. So once you have that, you can just use this in your React component. And if you see this, they have actually injected this Apollo provider and have a client here. I'll show a very simple, maybe let's look at the login. I have myself has not looked into the code, but let's look at the login page. It's taking the username, password, and it should make a GraphQL query somewhere. Username, password. Handle submit. Okay, let's just look for the query. Login, this is a mutation. And the mutation, if you see, is defined in this actually supports the GQL syntax. It's defined in this structured format again, although it is going as an unstructured format, you can write it in a structured format. And then I think this is auth context. And then once you pass that, this is the client that you created. Once you call a mutate method with the correct mutation and the variables, this is the variables that were being passed, you will get the data from the backend, and then you can use that to set the local storage, etc. Right? And if you see the main client in index app.js, it was using, where was it? I guess it was here. It was using the local storage to get the token. And then the next step, let's look at the home page itself. The home page is actually has multiple queries. Get top rated query defined here. Similarly, get movies by language, because we added a filter, is defined here. And these queries are actually used here, like use query, get top rated, get movies by language, get top rated, etc., etc. And I think it should have an handler. All of the data coming from the data.toprated_queries.map is directly operating on the response that we are getting from the GraphQL query. So if you, what I mean by that is, if you look at this query, movies by top rated movies, by the contract, let's see if we still have it. Yeah, if you see the contract, the response will follow data.top-rated movies. You can directly use that for hydrating your React components, and that's how we actually use GraphQL using that Apollo client library on the front end. This is all auto-generated, so I have very little context on how it actually, what code it wrote. So uh, it might not as per your expectation of what a good React component should look like for people who have vast amount of React experience. Cool. Any questions on this? Everything else is just more React components and more Apollo client integration. So I think if you see this get movie by, this is a movie details page. It has the movie by ID query, and somewhere in the down the line it will make the query and use that. See this? Yeah. So you have an error or data, or you just have a loading promise. You can just keep doing that. Any question on the integration, client side integration? I just wanted to share how actually it is used in a React app. And that's what I didn't want to make like this app very beautiful. I tried to actually get this the images also through the AI, and it was not able to figure it out. But if I have time, I will definitely publish this front end folder also to that workshop repository, so you can have the complete application. Any questions for on the client side itself before we get into another concept? Cool. I will get back to the slides. Can we share the slide? Cool. Here we go. So this is all until now. What we learned about was within the context of one GraphQL server. Now, when you actually work in the industry, you don't have a single service. It will be uh, it'll be a monolithic, if unless you have a monolithic system and there's only one service that serves all the requests, or that serves all the features, then only you will have a single service serving everything. Usually in a medium, small, even small, I would even usually in a medium to large size organization, I would also say that typically small organization also do that. They have broken their system into multiple microservices. It's not going to be the same service serving all the data. So let's just take a very simple example. We were looking at the login where we had users and stuff. Let's say we try to separate out the users concept or the users DB or anything related to authentication and identity into a separate microservice. And typically in a microservice architecture, you have tens and hundreds of microservices which serves the data and which does a very dedicated uh, which is responsible for a very dedicated domain capability. Now in our example, I just broke up our movie and user queries and mutation into different microservices. And if you see, if the moment you broke it into two services, the advantages of GraphQL start to fade away. This is very important because GraphQL, until now, what we were talking about was, hey, GraphQL is a single endpoint model. It is going to provide me all the data, all the queries, all the mutation behind a single endpoint. I just keep changing the queries for that same endpoint and I don't have to do anything. But once you have more than one microservice, you again fall into the trap where it is similar to the REST world, where client actually keeps track of what endpoint provides me what data. So in this case, client is knowing that the movies will be coming from a movie service. The host name of the movie would be movies.com, let's say, and the user data is coming from a user service. So I need to know where the user, what is the host for the user service, right? And doing this actually defeats the whole purpose of GraphQL and defeats a lot of advantages of the GraphQL that we were talking about until now, and a lot of benefits of the GraphQL. That actually introduce a very common problem in GraphQL, and everyone runs into that, and every company has this problem of, once there are more than one services, and there is it is very common to have more than one services in the ecosystem. How do you actually adopt GraphQL? How do we get the benefits of GraphQL in a microservices distributed architecture? And that's what we are going to talk about. So what we have currently is something called as federation, where a orchestrator sits in between the client and the microservices, and that's what is responsible for orchestrating the queries to the right microservice. Okay, so in this example, when if you see, the client can now make movie and user query together to the orchestrator. The orchestrator is smart to understand that the movie service belongs to the movie service, user's query belongs to the user service. It smartly splits the query correctly, calls the appropriate microservice behind the scenes, gathers the data correctly, which is title, rating, cover image from the movie service, and ID, name, and email from the user service, and it will merge those data together again and return it as a single payload to the client. Now, from a client perspective, client didn't even know or have information about the movie or the user service. The orchestrator has all the smartness built into that, and the orchestrator is kind of federating these queries to the right microservice. And this is a very common paradigm, or this is a very common technique, or I would say common solution that is used across the industry to divide the domain into smaller components and still leverage the benefits of GraphQL. Now, if you see, there's a lot happening here. there is an orchestrator which is like a proxy to the movie and user service, but it is not a dumb proxy that it is only forwarding the request. It is actually looking at the query of the client and making some smart decisions on what how to split the query and how to optimally call the microservices so that it can also provide performance benefits. In this example, it will actually make parallel calls to movies and service because these are not related to each other. These are independent components, so it will make parallel calls to movie and user service and get fetch the data whenever it is available. So the response time of this query that the client is making to the orchestrator would be the max of the response time from either the user or the movie query. That is one. Now let's imagine there are three queries in this in the if coming from the client: movie ID 1, movie ID 2, and user ID 1. The orchestrator is smart to understand that the two queries, movie ID 1 and movie ID 2, will be belonging to the movie service, and it will construct that query against the movie service, and it will only construct that one part which is user ID 1 against the user service. So that's what the role of the orchestrator is. Now let us understand how it actually does it. If you see in this example, GraphQL is all about schemas, right? GraphQL is everything starts from the schema and everything is revolving around the schema. So when you have a movie service has its own schema. When you have the user service, they have their own schema. They define their queries and they define their mutations. And they accept they can only accept their the query that is actually applicable to the their schema, and the movie service can only accept queries that is applicable to the movie schema. Now anything outside of that, it will reject. If you see, it's very strict with validations also. I was not able to query even typo in any of my field. So anything that is going to the movie service that is not correct in terms of syntax or in terms of matching against the schema, it will not process it. Now that is something that the orchestrator needs to be aware of. So what happens is, movie service and user service usually registers that schema to the orchestrator, and the orchestrator does a job called as schema stitching or schema composition, and it actually combines the schema from all the services that are registered and creates this one giant composed schema, which is, if you see in the below the orchestrator, that is the schema that the orchestrator will construct, will combining all the queries from the movies service and all the queries from the user service. It will do it for mutations also, but to demonstrate, I'll just add it to the I'll just add it query. Again, it also combines the type as well. If you see, it also took the movie type into this master schema and also the user type into the master schema. Now this is a tricky part. When you have multiple type, so now movie service team is a different team. Let's imagine movie service team is a movie team and user service is a user team, and that's how it works in the typically in a company. Usually services belong to different team. Now there's a different set of engineers working on the movie service, different set of engineers working on the user service. If you remember, I mentioned that GraphQL is very strict with the naming convention, and it is very strict that you cannot define the type twice in the schema. Now, if by mistake or by coincidence, if the movie team created a type movie and if the user team also created a type movie, there will be a type conflict problem when it actually tries to compose in the orchestrator and when it tries to compose a master schema. So that's why the naming convention becomes very important when you're developing a GraphQL service. Typically, you are in that shell of your local team, and we've actually seen a lot of problems in our company because of the naming convention and because of these conflicts actually occurring at a registration time to the orchestrator. Cool. So now the orchestrator understands what part of the schema, also in addition to constructing this master schema for the client, it also understands which part of the schema belongs to which service, and it keeps a registry of the schema versus the service in order to do the orchestration correctly. Yeah, so I see a question about that. It's like a load balancer. It's kind of, it's not a load balancer in general. Load balancer is the primary responsibility of a load balancer is to balance the traffic or balance the load across multiple instances of the same microservice. So in our example, we'll say that movie service has 5 pods or 5 in AWS EC2 instances, and a load balancer sits on top of the 5 instances, which is balancing the load against those 5 instances correctly. But orchestrator is not that. Orchestrator has a smartness built into it, where you have the registry, where you have a we have the registry, we have the schema composition. There is an actual algorithm that goes into composing the schema into a master schema, and at runtime it actually has smartness built into it, so that it looks at the registry and the information about the microservice and calls the correct microservice. So that is very important. If it does not call the correct microservice, it will probably be an error from that microservice, and you will never be able to fetch the data. So the job of orchestrator is a lot of business logic and algorithm actually happening. We actually created a orchestrator. If you guys are interested, this called as GraphQlt. In I will share the link. And I have a talk on the orchestrator itself during the GraphQL conference, because this is very common problem in GraphQL. Yeah, I'll just share the link. You'll get the link in the chat soon. So let's look at some more federation use cases. Now, this was a very simple way of federating. It's not a so you take all the, it's basically a aggregation, like it's aggregating all the queries and aggregating all the mutation. Very simple, straightforward way of federation. And at runtime, it knows, hey, movie is movie service, user is user service, and that's it. It's a simple algorithm that it can execute. But if you see this part, it's very, it's slightly complicated in the sense that let's imagine a movie service and a review service. I think I didn't update the DB, but assume that the movie service is dealing with movie DB, review service dealing with review database, which are different databases, different microservices altogether. Now, if from a client perspective, if you remember our query that we were looking at, movies had reviews inside the movie type. Okay. The query is on the top left, where movie has a review inside that. And since in our first initial example, we were all dealing with just the movie service, we kept the reviews inside the movie service. Now there's another iteration. We don't want to build a monolith. We want to separate the review service outside, and the review, all the data about the review belongs to a different microservice. But we still want the query to be like structured in a way that movies has a review attached to it. Now, what happens with actual using Apollo Federation to extend types is, Federation can be used for remote type extensions. I'll explain the remote type extension concept in detail. If you see the movie type, let's look at just the movie type on the top right corner. The movie type actually has a key directive, which is saying that, hey, I am a movie, my key is ID, which is something similar to a database key. Now, if you see the review type or the review schema, review also has redefined the movie type with the same key, and it is actually saying that ID is the key, and ID is an external attribute using that at external directive, and it has that act extends directive saying that I'm extending the movie type. And anything that is not external is what I will own, meaning reviews is what I am extending the movies type with. This is a very uh, uh, this is a very simple type extension, and it needs to be very surgically done, because in order to extend movies, the movie type itself needs to define a key that actually opens it up for extension. And in the federation world, it is called as entity. When you have a key annotation or key directive on the movie type becomes a movie entity. Meaning in concept, not actually in the schema, but it becomes a movie entity. Now, when it becomes a movie entity, the review type can now take that entity and attach its own attributes to that entity, which is the reviews attribute. The way to do it is they redefine the entity in their service, and they use that extends keyword to extend the movie type, movie entity. At runtime or at registration time, when the schema is being composed, the orchestrator is smart to understand that these directives are used to perform a uh, remote type extension style composition. And if you see the orchestrator schema, the reviews automatically comes under the uh, movie type. And see line number 10, right? Whatever was defined and extended by the review type is actually coming up. And the query, if you see that the client makes against the orchestrator, will now have reviews and under the movie. So the client doesn't know that this happened behind the scenes. The client is not aware of the remote type extension happened behind the scenes. And that's the power of federation, that any kind of remote schema stitching or remote type extension or federation happens behind the scenes. The client is just concerned about, hey, I need data, I need to get data, or I need to update data. I will just go to the explorer, which is the Apollo Studio, and the explorer is now an explore. The URL will be the URL of the orchestrator. Whatever is available in the explorer, I will start making queries and then start fetching the data. I don't care what the orchestrator does behind the scenes, right? And that's all abstracted from the client. And that's where this is another use case of directives, which has changed the GraphQL, which has changed the GraphQL and brought it to a very another level, where now you have a very common problem in the GraphQL world. It was promising a single endpoint model. The moment you split it up into multiple microservices, it didn't. It fell apart, right? Now, because it had directives, there are a lot of specification. Apollo Federation is the most popular. That's why it has the example. But you can see a lot of companies before Apollo Federation, and our company also created our own style of stitching schemas, or our own specification for stitching schemas using the GraphQL directives. And that's where directives becomes powerful. It can use for anything that you can think of, any kind of customization that you can build on top of the schema. And this federation is not something like which is just a concept. It is actually used by a lot of companies in the industry. GitHub, PayPal, whatever the industry that I was talking about in the first couple of slides, all of them actually uses federation, because these large companies are built of microservices. um, I have some resources on the federation at the end of the slide, but any questions on federation? I think that's something which is very important. Once you don't need to know that in depth, because once you start your GraphQL journey, you typically started with a single microservice. So whatever we learned until now, before federation, is where you start with. Federation will definitely come into picture the moment you want to go to production, or the moment you have more than one microservice in your system. And typically architects, and once you are at a very senior level, that's when you actually manage multiple microservice under your wing, and that's where federation actually they actually define what the there's actually governance and a uh, lot of thought that goes into what the final schema looks like, what the composed schema looks like after the federation schema, after the federation directives are added to the individual schemas. So the rule of the thumb is we are building the APIs for the client. So we need to understand that our APIs are cleaner for the client, are not leaking anything from the server, and are very easily consumable by the clients. Right. So I'll take a break and leave it for questions on federation itself. And this is like a not a very this will be a concept when you actually do GraphQL, and this will be a problem when you actually do get your hands dirty in production ready GraphQL. So it's the same thing. Query and mutation for federation is the same thing. Mutation is also a type. If you see, or if you see our mutation definition, right, in the service or anywhere, mutation also is defining the operations similarly, and you can also have mutation stitched into the compose schema. Input types usually are not extendable. Like for example, there's two aspects. The operations inside the mutation, meaning let's say add movie, add user, or add movie, add review, can be stitched together very easily. It's just aggregation. But you cannot use federation directives for the input types, meaning inputs are coming from the client, right? You cannot use those directives for the input types, which is the argument part of your query, not the return type of the query. You can only use it for the return type. Does it make sense? But like I said, directives can be used to extend federation to input types also. There is nothing stopping you from using federation for input types, and I'm sure if you search for it, you will find a lot of use cases and a lot of ways that people have tried to solve that problem, because even federation like 4 or 5 years back was not existing. So every company tried to solve it in their own way, and there was no standardization. Currently, a little bit of information about the existing landscape of federation. There's a lot of push to from the GraphQL foundations and the open source community to come up with an open source specification for federation, and not have Apollo define the federation spec or the federation specification to stitch schemas. And there is a composite schema group that is formed to come up with a new specification for federation, which will be standardized and released by the GraphQL Foundation itself, which is the official sponsors and the official maintainers of the GraphQL specification itself. So there is something that is happening already, and they already have some specification out. It's not widely used because there is no runtime implementation of those federation yet, but it will come out soon, and I think it'll just we'll just have one federation spec across across all the GraphQL specifications. But currently, Apollo Federation is the most popular specification that is actually used in the industry by big players and even small players. They have an open source library also. They just use that Apollo router library for Federation. And I've linked the docs once you want to learn more about Federation. There is good documentation from Apollo. Any other questions on Federation or uh, directives or authorization? So this was the last concept, guys. So if you have any questions, feel free to ask. Else we can wrap it up. I didn't want to go into the details of the Federation runtime because it will get complicated and it will confuse you. The only takeaway I wanted you guys to have is the microservices ecosystem or the microservices architecture uh, actually needs uh, Federation, right? We cannot do GraphQL in a microservice ecosystem without Federation or the orchestrator sitting in between the client and the microservice. It will be incorrect to use GraphQL in that way, where the client is uh, knowing that where the client knows that what endpoint does the movie service has, what host name does the review service has, what queries belong to movie service or what query belongs to review service. It will be unfair and it will be in not the right use of GraphQL if you have that. Anytime rule of thumb, if you want uh, to use GraphQL the correct way, it should be a single endpoint. The client should be able to get all the data behind a single endpoint. Cool. I don't think there are questions, but let me share one last slide. I have shared some links once the slide is shared with you. These are like mostly links from Apollo because Apollo is the most powerful and most popular client and server libraries. I've linked the GraphQL official specification, where you can learn GraphQL in depth. My agenda or goal from this workshop was to have you understand the power of GraphQL, and hopefully while writing a new service or microservice, you will have enough information to choose between REST versus GraphQL, or at least prefer GraphQL over REST after this workshop. And I hope that you guys can play around with GraphQL, use that in real systems, and use it in your projects. And uh, this workshop was probably helpful, right? Uh, so let me know. I've also added a link to my LinkedIn profile. If you want, feel free to reach out to me on LinkedIn, message me if you have any questions. I'll be happy to help you. Cool. Thank you. Thank you. It was nice. I really enjoyed sharing this, and I really enjoyed working on the project, creating this workshop for you guys. Like I said, uh, I had not used these libraries in the past because R is mostly about GraphQL, and we use Java in most of our day-to-day activities. And I wanted to try out the Apollo infrastructure, and it was very smooth. I used vibe coding, and I really enjoyed creating this project and creating this, getting this together for you guys. So have a nice day and enjoy. Thank you.